This is exercise 15.1, question number 1. Complete the following statements. Probability of an event plus probability of the event not E. The meaning is what? Probability of the event plus probability of not an event is always 1. The probability of an event that cannot happen is 0. Such an event is called as impossible event. Here, impossible event. Right? Because the event is not going to happen at all. Third one, the probability of an event that is certain to happen is 1, and such an event is called as sure event. Here, sure event. The sum of the probabilities of all the elementary events of an experiment is 1. Now imagine I have tossed a coin. So getting the head, the probability is 1 by 2, and probability of getting the tail is also 1 by 2. If I add these two probabilities, because this one and this one, they are the elementary events. Okay, when I add them, my answer comes as 1. Therefore, sum of all the elementary events, okay, probability of them is always 1. Now fifth one, the probability of an event is greater than or equal to 0 and less than or equal to 1. Okay, because probability of any event, see, we know this one, is always greater than equal to 0 and less than equal to 1. Okay, it is never negative. Question number 2. Which of the following experiments have equally likely outcomes? Explain. First, try to understand what is the meaning of equally likely outcome. Now here, suppose I am tossing a coin. Now, after tossing that one, probability of getting the head is 1 by 2 and probability of getting tail is also 1 by 2. That means head and tail, both of they have the equal chances to come up, right? So these type of events are called as the equally likely events. Now look at the first one here, what they are saying. They said a driver attempts to start a car. The car starts or does not start. Now imagine the car is in a very good condition. So car will start in one go only, right? Or maybe the car is good, but the driver is not that good. So car will start in the second go or might be third go. Or might be car is out of order, so it will not start only. So we cannot say whether it will start in one go or in many goes, right? So this is not the equally likely outcome. Look at the answer here. It is not an equally likely outcome because car will not start only when it is out of order, right? So it will not start only. Here, the second one. A player attempts to shoot a basketball. She or he shoots or misses the shot. Now here you see, maybe player is a very good player. That means in one go the player may shoot a basketball. And there is a possibility that player's mood is not that good. So maybe second or third attempt the player will shoot a basketball. So that also we cannot say. Correct? So look at the answer here. It is not an equally likely outcome because this game depends on many factors. There is a possibility that basketball court is not in a good condition. That is also one of the factors, right? Maybe the weather conditions are not good. That is again another factor. So it depends on many factors. Come to the next one here. A trial is made to answer a true false question. The answer is right or wrong. See, only two possibilities are there. Either the answer is right or the answer is wrong. Correct? So here it is an equally likely outcome because both have equal chances to happen. Right? Here, a baby is born. It is a boy or a girl. Only two possibilities are there. Either the baby is a boy or a girl. Correct? So both of them have the equal chances to come up. See here, it is an equally likely outcome because both have equal chances to happen. Question number 3. Why is tossing a coin considered to be a fair way of deciding which team should get the ball? Get the ball, not ball, it is ball, at the beginning of a football game. Now you see, whenever any game starts, in the starting they toss a coin because they consider that it is a fair way to decide which team will start what. Okay, now here you see. When we toss a coin, the possible outcomes are only two, either head and tail, right? Since these two outcomes are an equally likely outcomes. Remember, this is very important. These two outcomes are what? Equally likely outcomes. Tossing is unpredictable and is considered to be completely unbiased. Therefore, in the beginning of the game, always they toss a coin and then they decide. Correct? Question number 4. Which of the following cannot be the probability of an event? So probability of the event, you know, always greater than equal to 0 but less than equal to 1. So this negative number doesn't come here between 0 and 1. So this one minus 1.5 is not the probability of an event. Question number 5. If probability of the event is 0.05, what is the probability of not an event? We have this formula, probability of the event plus probability of not an event, which is equal to 1. Just we'll substitute the value here, 0.05 plus probability of not an event, which is equal to 1. Therefore, probability of not an event, which is equal to 1 minus 0.05, our answer is 0.95. Correct? Question number 6. A bag contains lemon flavored candies only. Malini takes out one candy without looking into the bag. What is the probability that she takes out an orange flavor candy? You only think, is that possible? Ki in a bag only lemon flavored candies are there and from that the orange color candy will come out? Not possible. It is the impossible event. Therefore, the answer is 0. Now the second one, a lemon flavored candy. So you take out any candy, it will be of lemon flavored only. So it is the sure event. That's the reason answer is 1. See here, probability of an orange flavored candy is 0 and probability of lemon flavored candy is 1. Okay. Question number 7. It is given that in a group of 3 students, the probability of 2 students not having the same birthday is 0.992. What is the probability that the 2 students have the same birthday? See here, probability of an event plus probability of not an event, which is equal to 1. This we know. So probability of the event, it means that having the same birthday, plus probability of not having the same birthday, they have given us 0.992, which is equal to 1. Therefore, probability of the event, which is equal to 1 minus 0.992, our answer comes as 0.008. Right? This one. See, probability of having the same birthday is this. Question number 8. A bag contains 3 red balls and 5 black balls. A ball is drawn at random from the bag. What is the probability that the ball drawn is red and not red? First we'll write down total number of balls. How many are there? 3 plus 5 is 8. Probability of a red ball. How many red balls are there? 3. So the probability is 3 by 8. Now next one is probability of not a red ball. How many not red balls are there? 5. So the probability is 5 by 8. Here. A box contains red marble, 8 white marbles and 4 green marbles. One marble is taken out of the box at random. What is the probability that the marble taken out will be red, white, not green? First, let us write down the total number of marbles. Okay, these are here marbles. So total number of marbles are 5 red plus 8 white plus 4 green, which is equal to 17. Right? Probability of a red marble. How many red marbles are there? 5. So the answer is 5 by 17. Probability of the white marble, white, how many white are there? 8. So 8 by 17. And probability of not a green marble. So out of 17, we don't want this 4. So how many are left here? 13. So 13 by 17 is the probability. Question number 10. A piggy bank contains 100 50 paise coin, 50 rupee 1 coins, 20 rupee 2 coins, and 10 rupee 5 coins. If it is equally likely that one of the coins will fall out when the bank is turned upside down, what is the probability that the coin will be a 50 paise coin and second one will not be rupee 5 coin? First, we'll write down this one in a systematic way. See here, 50 paise coins. How many are there? They said 100 coins are there. Rupee 1 coin. So 50 are there. Rupee 1, 50 coins. Rupee 2 coins, 20 are there. Here 20. And rupee 5 coins are 10. So here 10. So total number of coins are 180 coins. Now first question they asked, what is the probability of a 50 paise coin? So how many 50 paise coins are there? 100. So 100. And total number of coins are 180. So cancel this one. 2 5s are and 2 9s are. So the answer comes as 5 by 9. Second one, not a rupee 5 coin. Not a rupee 5 coin. It's supposed to be rupee 5 coin. So not. So 5 rupee coins I will just remove. Out of 180, 10 coins are gone. How many are left? 170 by 180. Just cancel this 0 and done. Answer comes as 17 by 18. Question number 11. Gopi buys a fish from a shop for his aquarium. The shopkeeper takes out one fish at random from a tank containing 5 male fish and 8 female fish. Just see here in the figure. What is the probability that the fish taken out is a male fish? Total number of fish? 5 plus 8, which is equal to 13. Probability of a male fish. How many male fish are there? 5. So 5 by 13 is the probability. A game of chance consists of spinning an arrow which comes to rest pointing at one of the numbers 1, 2, 3 and so on till 8. Just look at the figure here. We have spinning wheel and here the pointer is there. Which one will point at one of the number? And these are equally likely outcomes. What is the probability that it will point at the following conditions? See here. Now here, as they have given us the 8 numbers, correct? So total 8 numbers are there. They are asking us what is the probability that 8 will come up. That means the pointer will point at 8. So 8 is the only one number out of 8 numbers. So the probability is 1 by 8. Second one, what is the probability of an odd number? See the odd numbers. This one is odd, this is odd, this is odd, and this one is odd. So this way, how many numbers are odd? 4 numbers are odd. So here I'll write down 4 by 8. So it comes as 1 by 2. Now probability of a number greater than 2. Now greater than 2, all these numbers are greater than 2. That means 6 numbers are there. So here I'll write down 6 by 8 and now 3 by 4. Now probability of a number less than 9. All these numbers are less than 9. Now you keep on spinning that wheel number of times, the pointer will point at the number which one will always be less than 9. Correct? So that means here 8 by 8 I have to write down. It means that it is the sure event. It will come as 1. Come to the next question here. Question number 13. A die is thrown once. Find the probability of getting a prime number, a number laying between 2 and 6, and an odd number. So whenever we throw a die, now look at the outcomes then. Only these outcomes will be there. 1, 2, 3, 4, 5 and 6. That means total number of outcomes are 6. Now they said, what is the probability of a prime number? Now we'll find out the prime numbers out of these numbers. Remember, most of the time you write down 1 as prime, but 1 is not a prime, not the composite number. So you are not going to count 1 as the prime. Now see, 2 is prime, 3 is prime, and 5 is prime. So 3 numbers are there which are prime numbers. So I'll write down 3 by 6, which comes as 1 by 2. Now, probability of a number laying between 2 and 6. So you are not going to count 2 and 6. Only the numbers between 2 and 6. These 3 numbers are there. So 3 by 6, which comes as 1 by 2. Now, probability of an odd number. See the odd numbers? 1 is odd, 3 is odd, 5 is odd. Right? So 3 numbers are there. So 3 by 6, which comes as 1 by 2. Question number 14. One card is drawn from a well-shuffled deck of 52 cards. Find the probability of the following. Now, what is this deck of 52 cards? Some children, they don't know it. Just see it here. Now here, this symbol is called as the spade. And this A means S. A, C, E. It indicates it is the first number card. Okay. So here, S is there. That means first number card is there. And 2, 3, 4, 5, 6, 7, 8, 9, 10. These are the number cards. Then Jack, Queen and King. These are the picture cards. So we can say them as the face cards. So total cards are 13. 13 spade cards. Okay. And they are in black color. This symbol is for diamond. So for diamond also how many cards are there? 13 cards. This symbol is for clubs. For clubs also 13 cards. This is hearts. For hearts also 13 cards. Now total number of cards are 52. Now total number of red cards. See, diamond 13 and hearts 13. 26 cards. And total number of black cards are 26. Because spade 13 and clubs 13. So in this way 26 cards. Total number of face cards. See, these 3 cards, these 3 cards, these 3 cards and these 3 cards. 3 fours are 12. So total number of face cards are 12. Okay. Come to the next one here. Now they asked, now looking at those cards, we have to answer these questions. Okay. Probability of a king of red color. So how many kings are there of red color? 2 kings. So 2 by 52. Now it will come as 1 by 26. Now face card. How many face cards were there? 12. 12 by 52. Now here 4 threes are and here 4 ones are and 4 threes are here. Okay. So this one 3 by 13. Now probability of a red face card. Red face card. See here. These are 3 cards and these are 3 cards. That means there are 6 cards. So 6 by 52. So once again we'll reduce it. Here 2 threes are and here 2 twos are and 2 sixes are. So 3 by 26. Probability of the jack of hearts. How many jack of hearts are there? Only 1. So it is 1 by 52. Now the next one. Probability of a spade. There are 13 spade cards. So 13 by 52. So 13 ones are and 13 fours are. Answer comes as 1 by 4. Probability of the queen of diamonds. So only one queen is there of diamonds. So 1 by 52 is the probability. Right? Here. Question number 15. 5 cards. The 10, jack, queen, king and S of diamonds are there. So only these 5 cards are there. Are well shuffled with their face downwards. One card is picked up at random. What is the probability that the card is the queen? Now out of 5 cards, only one queen is there. So probability of getting the queen is 1 by 5. Right? So here we'll write down, see. The first one, probability of getting a queen is 1 by 5. Now in the second part what they are asking, if the queen is drawn and put aside. So we have kept the queen aside. Now how many cards are left? Only 4 cards. What is the probability that the second card picked up is an S? So out of 4, one card is of S. So the probability of getting the S is 1 by 4. Now they are saying what is the probability that getting a queen? But queen already we have kept aside. So in all those 4 cards, queen is not present. So the probability of getting queen once again is 0. So 0 by 4 means 0. Question number 16. 12 defective pens are accidentally mixed with 132 good ones. It is not possible to just look at a pen and tell whether or not it is defective. One pen is taken out at random from this lot. Now determine the probability that the pen taken out is the good one. First we'll write down the total number of pens. 12 are defective and 132 are the good ones. So total number of pens are 144. Now probability of the good pen is what? 132 by 144. Now we'll divide it by 4. 4 3s are 12, 4 3s are 12. Here 4 3s are 12 and 4 6s are. So here 33 by 36. Once again we can reduce it. 3 1s are, 3 1s are, 3 1s are and 3 2s are. So 11 by 12. Correct?